Are we ready? Folks, can you hear me through the microphone? Can you hear? Can you hear now? Great. Better. All right. So, welcome back. How's the first assignment going? It's going well. So as you've seen, the logic behind the assignment is not that complicated, right? We try to help you out with providing the tester and providing the virtual machine also, so that it will help you test your code, test it with the environment that we're going to test with also. So, deadline, just a reminder for you, it's this Wednesday, which is in a couple of days, by the end of the day. So midnight. Before midnight on Wednesday, please make sure you submit your code. There are, every year, like I tell people, please submit well before the deadline. Okay, don't wait till the last minute to submit your code to Blackboard. And even though you want to submit your code, like the assumption is that everyone will submit at the same time, Blackboard can allow that. So Blackboard will be available. The system was high availability for the size of this class. So which means something. I'm saying that because there are like excuses like whatever, something happened to the computer the last minute and I couldn't submit the assignment, right? Please, I'm not saying that you do this on purpose, but if there is a possibility that something's going to happen to the computer, have a backup tonight or tomorrow, right? And submit it on time, okay? Please.
Multiple submissions allowed?
Yeah. And if it's not, it's supposed to be multiple submissions allowed. So if Blackboard is set to do that or not, should be, right? We used to do it that way all the time. We submit multiple times. But the last attempt will be the one graded, okay? So please don't run into, like, I don't want to hear these kind of excuses of like something crashed the second before the deadline or anything like this. All right? So submit well before the deadline. If there is a possibility of a crash, right? So you cannot predict that, of course, right? But you know what I mean, okay? So if there is a possibility, please do it beforehand, right? Also, this is just a reminder, and I know you guys know that. This assignment and every single assignment, I'm not talking about the project, talking just about the assignments, the 5 assignments we're having. Every single student will have to solve the assignment on her or his own, okay? And your work needs to be original. It shouldn't be a cut and paste from the internet. It shouldn't be a cut and paste from a friend of yours in the same offering of the class or previous offerings of the class. So just a reminder, right? So please make sure don't do that. And these kind of things can be easily, these days with the tools we have, it's just like that. It can be detected very easily, right? So try not to do that. This is not good, right? And again, as per the syllabus, this will lead to an immediate F in the class, and the incident will be reported to the dean's office, okay? You don't want that, right? So it's just 5%, even if you didn't do your best, right? If you can get as much as you can from this is good, right? It's better than failing the class, right? So, and also it's better for your inner peace, right? I've done something on my own. This is good. You should be proud of it. So this is just a reminder. I know that none of you will do that, but just a reminder. For the assignment, a very good tool to get your inquiries answered is the discussion board on Blackboard. Why? Because it's a centralized location where we look at all the questions and we answer them. Second, and this is actually more important, is I want every single person to look at the discussion board and other people questions. Even if the question looks obvious from just the title of the thread. Maybe there are deeper conversations inside. Look at it. You wouldn't lose much, right? It's not, you will benefit more than losing, okay? And some of your questions may have already been answered. So if you look at it, you will save your time, you will save every other people's time. So keep this into account. It's a really useful tool. I've received several questions, the same question again and again and again and again, right? So if you can do a favor for your classmates and ask the question on the discussion board, everybody will see the answer and it will be a service you do to your classmates. Yeah. So this is again a recommendation for this assignment and future assignments, okay? Sometimes the requirements of the assignment may not be clear. I understand that. We all don't speak the same language, right? When it comes to explanation of the assignment and everything, everybody's coming from a different background, so we might read and write things differently. So it's understood. So if you want something to be clarified, we understand that, right? So this is why the discussion forum, it is good. Sometimes you might find, again, because it's human error, you might find an error in the tester document or something like this. If you find something, please report it immediately. And we will be very responsive to these kind of things. Okay? All right, so the programming assignments we will have from now, it will be like the first assignment we're having, okay? So some of them will build on each other. So we'll have like this small simulated distributed database system, okay? And the project will be a different story. Do you guys have any questions? General questions, please. If it's a very specific question about the assignment, discussion board, please, right? So, but if it's something more generic, it's fine.
Yeah, with respect to the data, that file, waiting for that file.
Yes.
It is taking too much time to load.
Too bad, man. Yeah? Yeah. Shouldn't be. Shouldn't take too much time. It shouldn't.
It is 256 MB.
Please?
Because it is 256 MB, so megabytes.
256 megabytes. So what is the speed of the processor you have?
I have a good processor is 5.
Think of the speed of the processor, memory bus, how much bits per second it can do, and think of the size of the data. You said 256 megabyte. And if you believe that the system that you have is very, it's weak, it needs to do that in a very long time, we can talk about that. But I'm telling you that we will run this on, guys, let me just answer a question. Wait a minute. We will run this on a commodity machine, and we ran this code on a commodity machine before. Commodity, it's a machine that any one of you can have, and I have. It's not like a supercomputer or anything. And it shouldn't be that slow. Am I making sense? Or 256 megabyte can be easily loaded into memory. It can be loaded into memory very fast. I'm telling you this. So do you want me to tell you how to load the file in the memory, or? No, because I'm not going to tell you how to load it into memory. Believe me. No. Wait a minute. I'm not. I'm not saying the question is bad or anything like this, but I want you to think how to do this efficiently. As part of the assumption, I want you to think how to do these very simple things that you've been doing in a very inefficient way in the past. I want you to think how to do it efficiently. Sounds good? Right? Please.
Will be given feedback.
I will stop taking questions if I hear more noise, please. Okay? Thank you. Please.
Will we be given feedback on the kind of code we have written on the efficiency or optimization assumptions?
No, but if it's too slow, I'm just gonna move on, right? So the grader will just move on. So move on and grade the next assignment, right? And if it's slow, it will move on. So it's not like the fastest will get a higher grade or anything, but there is like if it stalls the grading, it will just move on, right? Please.
Why should we include the citation?
Sorry, what citation talking about?
Why should I include the citation if we are deriving that logic from some site website and we are picking it?
Yeah, but I mean, again, if it's algorithms are actually not all of them you're going to invent, right? So it's understood that you might take some logic, you might be inspired by something you read on the internet, but you shouldn't be cut and paste from other code, right? So yes, include it in the documentation, please. Other questions? Please.
The table name and column name of the database is a case.
Don't make me whistle, right? Please.
The table name and column name of the database is a case sensitive. Do we need to care about that?
Let me tell you something. There is a lot of questions about sanity checks in the program, which is great. It tells like how good a programmer you are, right? Any of you. But we don't focus much on these. As long as you pass the tester, okay, you're fine. Okay. But if you do that, you wouldn't lose much. You wouldn't lose anything. It's great if you do sanity checks and everything, right? But as long as you pass the test, you're okay. I hope that makes sense. Please.
The tester uses tester.dat. The tester uses a separate file. It doesn't use ratings.dat. So you should test with ratings or you should test with tester.dat.
So I didn't hear everything, but let me say it again. Maybe I got it. So you say there is a file called ratings.dat. That's the main file, and we load the ratings from that one.
Yeah, that is supposed we are supposed to download from internet. The tester.cs which is given, it uses a separate file called tester.dat. So
Your load ratings should take a path to the file, right, and load it. Sounds good? And the file will be in the same exact format in the assignment and in the one you download, which is the same as the one you download from the internet. Sounds good? Awesome. Please.
What do we include in the document?
You include in the document your code and the documentation. It's the script that you've written. And as long as this script you copy and paste in for the image that we shared with you and it worked on that virtual machine, you're good because we're going to run the code on the same specs like this machine. This is why we share the machine with you, the image with you.
Should we include a document like explain how we read the file?
Okay, yeah, please. And in the documentation also in the script itself. Okay, but don't change the functions, right? Should be the same because otherwise, again, it's going to be like it's taken so much time, it's going to skip, right? And it's going to give not a so good grade if it doesn't have the same name, right? Because it will deal with it as it's not existent, right? All right, let's move on, okay? Again, more questions, discussion forum. One disclaimer, last thing about the discussion forum. If it's the last minute, it's going to be hard to communicate the response back to you. I mean, if you post a question on discussion forum in the last minute, it's it's going to be a little difficult for us to get back to you before the deadline. So, which means that I encourage you to submit your questions as soon as possible. And that means in the future, for future references, start on the assignment as soon as possible and get all your questions resolved before the deadline. All right? And yeah, so it just makes sense. You guys understand that. So it makes sense if a last minute question or in the last couple hours, like we receive like 100 questions, it's going to be really hard to handle all of these in the last minutes. So keep that in mind, okay? Keep that in mind when you do. And this is why I always recommend start early on the assignment, okay? Okay, let's move on. So last time we talked about fragmentation. We discussed horizontal fragmentation, primary horizontal fragmentation, derived horizontal fragmentation, vertical fragmentation, hybrid fragmentation, right? And then we talked a little bit about replication. How can we replicate fragments? The benefit of replication and when replication is challenging. And we talked about the problem of allocation. How can we have an optimal allocation of the fragments and the replicated fragments across distributed sites in a distributed database system? So all of this, we didn't think much about how to do queries, how to process queries in a distributed database system. So we cared a lot about how to distribute the database, how to fragment it, how to replicate it, how to allocate these fragments. But we didn't think, okay, now that we have fragmented database, distributed database across sites, and replicate it sometimes. So how can we run queries? Queries come from like SQL queries imposed by the, or like posed by the application to the system. How can we do that? So the idea, you have a high-level user query, and in relational database, this is SQL, but in other kind of database, it can be anything else. It's just like a query language. So high-level user query, and you have the query processor, and it transforms this high-level user query into low-level data manipulation commands. So the query language is, in our case, we're going to focus more on SQL because this is the most widely used query language. And speaking of which, do you guys know, speaking of why we do SQL, why I mention SQL all the time, I want you to have like a wild guess for databases with different query language and different models. Like we use SQL because we have the relational model of a database. So how much is the relational model used as compared to all different data models in terms of the market, people using? If you want to have like a market share of SQL compared to all of them, all other models. What do you think? What is your guess? Just give me a wild guess. 90% SQL and 10% everything else?
90% just non database.
Okay, so other guesses. What is that? Any guess, just wild guess. 40? 40% SQL and 60% non-SQL. Okay.
20%.
20% SQL. Yeah. Why I'm asking that question, let me just be, I'm going off, like it's off-roading now, but I'll come back quickly. So why I'm asking that question, because a lot of people that are taking data systems class like this, or system class, they're very much interested in NoSQL databases, and they want to learn that more because they think this is, for some reason, I don't know why, this is cooler, or this is more, like much more interesting than SQL. Might be, I don't know. But, so the gentleman in here was actually very close. He said 90% SQL and 10% everything else. In 2015, they did a market research, and they figured, you're not exact, so sorry, but you're the closest. So they figured that of all database systems in the world, all people using databases in the whole world, SQL, or the relational database, is used in 98% of the market, okay? And only 2% of the market is using all the other models or something, yeah. So 98%, this means that if you want to work, so all the jobs that you hear about, data scientists, whatever, data analytics, any of these kind of things, right? If you don't know SQL, right, you're not going to get the job at all, right? Because most of these jobs, you need to know SQL, and you need to be good with it, and you need to know how to do either data manipulation, curation, analytics using SQL, right? So even the big data platforms that everybody's excited about these days, they did their best to support SQL. Like Hadoop supports SQL, Spark supports SQL. So why is that? Because they know that everybody's using it, right? So this, I mean, again, some people will argue that SQL is outdated. It's not outdated, actually. It's a must for anyone who's graduating and anyone who's looking for a job in the data field in general, okay? So this is just off-roading to explain why we use SQL as the main topic. However, a lot of the concepts in the distributed database system we're talking about here will work with SQL and non-SQL databases as well, like with relational and non-relational, okay? A lot of them will work across the spectrum, but we use the SQL databases as our main example here. Okay, coming back to the topic. So query processing. So you have a query language like SQL, and you have a query execution methodology. And the query execution methodology is basically the system took the SQL query in a very declarative language from the user. And then it has to decide what is the best strategy to run this query inside the system. So a best strategy is basically, it says how can, like if I have a lot of computers to run the query, so how many of them can be involved to process this query and return the answer fast to the user. So we will have different optimization parameters, and based on that, the best execution strategy will be decided. And you have a very important component which complements the query execution methodology, which is the query optimization. And the query optimization, again, it's a step between the query language, the declarative query defined by the user, and the query execution. So, and it takes that and find the best query execution strategy, and then query execution methodology runs accordingly. So let's take examples. Why we have this, why we're bothered by query optimization, query methodology, and everything. Because obviously there are so many ways to run the same exact queries. And so many ways of run it that will return the same exact answer to the same exact query. So which way we need to pick to run this query? Is it the user responsibility or the system responsibility? In database system, it is the database system responsibility to decide what is the best execution strategy. Let's take an example. So this is a query. We've looked at these tables before. Employee and assignment. Excuse me. So employee is basically a table that has all the employees. An assignment is a table that says which employee is assigned to which project. Okay. And this query is basically joins the employee and the assignment table and return all the employees such that the responsibility of this employee is manager. He manages this project. Right? Very simple query. You can, a lot of, like if you have this kind of database, it's an application for this kind of database. There are two strategies to run this query. And these are the examples of the strategies. First, to run this query, first strategy does a cross product between the employee and the assignment table, which means cross product means for every single row in the employee, you just map it to all rows in the assignment table. So you do this cross product, like blindly just put every pair of rows together. Okay? an employee and assignment. And for the result set, you go ahead and do the selection on both the join key, which is the employee number, and also on the responsibility, which is manager. So you do a cross product, put everything together first, and then on top of the cross product result, you do the filtering, you do the selection. Again, this sigma, if you haven't taken relational algebra before, this means selection, filter, based on these predicates. That's the first strategy. Another strategy is basically do the selection on the assignments, because we have a predicate, which is responsibility equal manager, on this exact table. So you do the selection first here. You get the subset of all the assignment rows that has a manager attribute in it. And then you join it with the employee. And the join here, it's not a cross product. It's actually while you put two tuples together, you check whether the employee number is the same, is equal. Okay. And then, of course, there is a projection. For both cases, there is a projection, which is the pi symbol here. Projection means you want to only the employee name. So these are two totally different strategies, and both will return the same exact result, correct answer to the query. So in a centralized database system, which one you think would be better? Who thinks it's the first one? Who thinks it's the second one? Okay, there are some people abstaining. It's not Congress, right? There is one answer to that, right? Yeah. All right. So the second one is actually, in a centralized system, is usually the system's choice. It's actually always the system's choice for the query execution strategy. And you probably know the reason. It's that you push the selection down. Instead of doing this kind of huge cross product and have this huge result set, you do the filtering early on, right? So this will yield a more efficient query execution plan and will return the answer faster to the user. Perfect. So this is in a centralized database system. So if you've taken CSE 510 or in here in the database system, I will tell you this is the best plan, right? But for distributed database system, it may and may not be. So let's take an example to understand this more. Assume again you have 20 managers, which mean you have 20 rows with the responsibility equal manager. And instead of a centralized database system, you have a distributed database system like this. So that's the assumption. A distributed database system, you have 5 sites, and site 1 will have part of the assignments table. Site 2 have another part of the assignments table, and the employee table is actually distributed between site 4 and site 3. And it's partitioned based on this kind of range partitioning here, the same thing you've done in your assignment. So employee, like the employee number less than or equal E3 here is larger, less than or equal E3 here is larger for both tables. One way to do the fragmentation. It is actually distributed that way. And the result needs to be reported in site 5. One way to process this query is, somebody can tell me, can anybody tell me? What is a very straightforward way to run this query? Again, remember the query needs to join employee with assignment. What is the very straightforward way to do that here, in this case? Please.
Extract the table into one and then execute the query.
Awesome. So bring all tables that are distributed together again in the result site, right? And run the query. This is what you want to say, right? So something like this. So everything in site 1, assignment 1 and assignment 2, employee 1, employee 2, and all in the 4 sites, you transfer them to site 5, which the result needs to be in this site, and then you run the query. Do the strategy that is, any of the strategies that are centralized. Okay? Fair enough? Is this the best strategy? I don't know. I mean, how you say? I mean, just if you don't know. So, are there other strategies to run the same query? Obviously, there is, right? Another strategy is something like that. This basically, instead of communicating everything, sending everything off to the results site, you send the assignments to site 3, assignment 1 to site 3 where the employee is, and send the other assignment to site 4 where the other fragment of the employee is. Do a partial join, and then for the result of the join, send that to the results site and do the union, and this way you get the results. You guys understand why this will return the same exact answer? Understand that? So basically you have, for all the assignment and the employee that are actually have the same employee number, because they're fragmented based on the employee number, you put them together. And this way you've done the total join. You didn't lose any information. And then you send it off, employee 1 dash, employee 2 dash, to the result site, do the union, and this is the whole result that you need. This is another execution strategy. Is it better than the other one? I don't know, right? So how can we know? What are the factors that will determine whether this strategy is better than the other strategy or not? Time. So the time to finish processing. And how can we, if we want to split this down into different factors, how can we determine that? Please.
Amount of data that is being moved from one site to another.
Amount of data that is being moved from one site to another. Please.
So the amount of time it takes to move that data between the two sites.
And how much time it takes to move a piece of data from one site to the other. Okay? So it is the amount of data and the time to transfer one unit of data to the other site. That's one thing. But is there any other thing? Please.
Amount of background queries that are executed.
Amount of what? Queries.
Yeah.
So after you move the data, you need to do some kind of processing, local processing on this site. So, which means the local processing time. So how much data we process here, and to simplify the unit time used to process a unit data, something like that. Please.
The number of sites you have to send it to more sites.
So if you're sending the same piece of data to more than one site, you have to take this into account. This will count as two times, not just one time. So, please.
Even the size of intermediate tables.
The site of the intermediate tables, which is
From site 1 to site 4, we are joining something like that will be an intermediate table.
so this is again the local time you like for each site to process this query. Exactly. Please.
The amount of parallels you can get in your query time.
The amount of parallelism you can get in the query plan. So which means if there are two things that run in parallel on two different sites, you can get it. It's not the same thing as you run it in series on one site. All of this is perfect. Okay? If the assumption, if I told you what is the total cost in terms of the resources used to run this query, excluding the parallelism part, I just want to calculate the total resources, okay, in terms of the unit time, okay, used to process these two planes. How can you calculate that? So again, this is the strategy we've seen first, and this is the strategy we just had in the previous slide. And this is the query we're running, and this is how every site, what kind of information every site has. And let's assume we have these assumptions. So the size of the employee table is 400, the size of the assignment table is 1,000, and you have 20 managers, because we're looking for the filter on manager here also, responsibility for manager. And the tuple access cost, and this is again the local access cost, for one row is 1 unit, and the tuple transfer cost is like the cost of transferring one tuple across 2 different sites is 10 units. What I want you to do right now with your neighbors, I want you to calculate roughly the cost of each of these strategies. With your neighbors, please. That's enough. Yeah. Thank you for trying. Yeah. The reason I whistled is that I spoke in the microphone like 2 times to ask you guys that's enough, but the noise was very loud, so I used my strong tool. All right. So who wants to tell me for this strategy? Just the cost of the first step, which is the first step, as you can see, produce something called assignment prime or assignment dash. That is, part of it is assignment 2 and assignment 1 and assignment 2 prime. So what is the cost of just generating that? So no, just please.
So 1,000.
Why?
Because we must check all the assignment to find the maximum. So that's look at all the assignments. So totally is 1,000. So it's local access. So that's 1,000 times 1.
So gentleman has a point here. So he's saying that to produce, just wait a minute because this is important. To produce assignment prime, you need, the cost of that is 1,000. And his reason is, in order to produce that, you need to access all the 1,000 triples in the assignment table. This is true. If this selection is actually run using something we call a file scan in database system, which is the least efficient method to get the result, especially if you have a very selective query like this. Selective predicate. So it is true if the local query execution plan is a file scan, which is I need to scan the whole table to get all the assignment rows that have responsibility for management. But what if I have an index that can direct me, like whenever I have this predicate, it can take me to where these tuples are directly, okay? And they're all stored together sequentially using an index. So what is the cost in that case? Please, you're in. Everything, creating assignment prime, which is assignment 2 and assignment 1 prime. To be what?
20.
It will be 20, exactly. So it depends, again, on the local execution plan that you have for each of these assignments. If there are no indices whatsoever, if the data is not sorted, and you need, in both cases, you need to do a full table scan, it will be 1,000. But if you have an index, and if you've taken CSE 510 or similar courses before, if it's a clustered index, which is very popular kind of index in the database system, it will be 20. Why? Because they have 20 managers. So I can directly access the 20 managers. The index will help me do that. So the most efficient plan, if I have an index, it's 20. So there's no wrong answer here, but if these are the two answers to the problem. It depends on what is the local execution plan. All right, so that was the first step. So we have 20 as the most efficient plan. The fastest way we can get here is 20, or like the least cost. The cost of transferring assignment prime from both site 1 and site 2 to site 3 and site 4. By raise of hands, please. How much is that? Please.
200.
200. Why?
Because on a whole we have like 20 doubles which need to be transferred and each double costs 10 minutes.
Perfect. So we know that each tuple has a transfer cost of 10. And we have 20 managers that we created, 20 tuples created from this first step, and they need to be transferred. So multiply this by 10 to get 200. Very simple math. We know what is the cost of this. Perfect. What about this step? Which is the step where you take assignment prime, the both sides of it, and do a join with the employees existing here in site 3 and site 4. So what is the cost of this? So again, remembering that we have 20 tuples transferred already there. So what is it? Someone in the back raised his hand. Please, and raise your voice, please.
It's 28. If it's
What?
one-to-one join.
What is the cost?
20 if it's one-to-one join.
If it's 1-to-1, it's 20. So explain that again.
So if in case one assignment matches with one employee, then there would be just 20 employees who made those 20 assignments. So I just need to access one employee per assignment. So that would be 1 double, even an index again. Without an index is again 400.
Okay, so you're saying if there's no index, you need to take those 20 and multiply them by 400?
No, I just need to fetch all the employees and I can match my employee the assignments into that. So it's just searching everything.
No, but if you don't have, you said if you don't have an index,
Yeah.
you just want to do the join.
Yeah, 400 into 20.
400 to 20.
Yeah.
Okay. And if you have an index?
It's just 20.
Explain why.
Because I know the employee number and it's assuming that it's a one-to-one match, I just need to fetch the corresponding
So you need to access
20.
the 20 assignments and the 20
employees who
employees.
make those assignments.
so it's going to be 40.
No, because assignments are already got, right?
Yeah, you transfer them, but you need to access them to do the join, right?
Yeah, in 40.
Right? So it's 40. So it depends again if you have an index or if you don't have an index. But let's assume you have an index. So the cost of doing that is using index nested loop on both sides is 40. Okay. So it's 10 times 2 times 2, right? So which is 40. So what is, again, if you do not have an index, the problem is that you always resort to in joins. I'm not, if any of you have taken CSE 510 before, or again similar classes in other institutes, there are different ways to do the join. Join means, again, you have two tables and you join them together, and there is a join condition like this one, which is based, you want to make sure the employee number here is equal to the employee number in the other row from the other table. So there are several execution strategies when it comes to executing this join. One execution strategy is the nested loop. That's a very simple, straightforward execution strategy. So what you do in the nested loop is that you take the outer loop will be one of the relation 1, the inner loop would be relation 2, and for every tuple from relation 1 and relation 2, you check this constraint, which is employee number, and if it matches, this tuple is in the result set. If it doesn't, you keep going doing that all the way. So this is called nested loop, and the cost of this is basically the size of the first relation times the size of the second relation. So that's the cost of this. The second, another way to do the join is that if you have an index on one of the relations, you can do something called index nested loop. It's again a nested loop, the same as the first strategy, but instead of loading every single time, for every tuple, you check it against all other tuples in the other relation, you probe an index to get the corresponding tuples in the other relation. Okay? So it can sometimes be more efficient. There are other strategies in also to do the join. There is a join called the sort merge join. And the sort merge join basically sorts the two relations first based on the join key or the join attribute. And then once you have them sorted, you can just scan both sorted relations. In just one scan, you can do the join. That's called sort merge. There is something called the hash join. Okay, there are different join strategies, but what I've explained to you are the most like every database system that you're using, MySQL, Postgres that you're using for the assignment. Whenever you do a join, it decides what is the best strategy among these strategies that I explained to you. Okay. This is just, again, in the middle, just to remind you what are different strategies. So in this case, we consider both with the index and without the index. No index, no sorting, nothing at all. It's a nested loop, so it's a side of the two relations. But with the index, or with some kind of sorting in the data somehow, or clustering in the data, you can get the cost of 40, as we explained here. And we already explained how we got that. Okay. So this is 40. What about the step of moving things around? Like we have employee dash now, or employee prime, sorry. So you want to move this around. How much time it takes? Remember, the 40 that we calculated originally was actually the cost, not the number of tuples created. So please, back there.
22 pulls left times 10 you can see
200. Perfect. So he caught my my note here. It's like I said, because a lot of people, you said the cost before was 40, so they will take 40 and multiply by 10 now, right? 40 was the cost of that step, but the result was 20, because we have 20 managers. So we got 20 times 10, we got the 200. So, and once you have the result in site 5, you already have the result set, because you don't need to do anything. This union is nothing. It's just, they're both there, right? So you have the result already. So you guys understand what is the total cost of this one? Every single step. So let's move to the other one. The very first plan or strategy we talked about. What is the cost of that one? Raise of hands, please.
Sorry to interrupt, but could you tell me how did we end up calculating the cost to be 40 for the site 3 and site 4?
Good question. So when we had assignments, we had 20 of them, right? But these 20 have a corresponding 20 in the employee.
So you're going to check each row, you're going to check with all the other 20 rows, right?
Yes.
It's going to be 20 into 20 rows. It's not 20.
No, it's not like this. It's for every... Okay, how can I explain this? So you have 20 rows, okay? And you have 20 rows coming from the manager, okay? And then for each one, for each site, you have to check all the employees that matches each of these 20, right? There is one employee that match in each one of them. So this is why this is actually 20 times 2, as if you're scanning both of the 20 one by one and you're matching them together. In assignment and employee. And this is the best strategy you can run this query in. So in this case, we didn't do a nested loop. A nested loop, you will do this kind of multiplication kind of thing that you did. But in that case, it will be 20 times 400, right? So it's not 20 times 2, okay? Okay, so second strategy, this one, the very first one we discussed. So by raise of hands, what is the cost of this one? Please.
4,020,000.
Sorry? Raise your voice, please.
4,020,000.
4,020,000. Wow. Why? No, you don't have to be sorry. Please explain. There's nothing wrong. Go ahead. I want to understand. Yeah. Just guys, please.
1420.
Tell me why. Tell me why. I want to understand what is the forget about the final number. Just what is the cost?
So we put 1,400.
Please. Yeah. Yeah, I know how to whistle in different ways. Yeah. I brag about this. Yeah, it's fine. Yeah. Please. Yeah.
1,400 are the total pupils.
1,400? 400 and then okay. And then times
10.
times 10. Okay, so this is
14,000.
14,000 exactly. And
And then we are selecting it, so 20. We are crossing it and then selecting it, it is indexing and
yeah, but remember this strategy is the one with the cross product. Yeah. So this strategy, remember this? This is a cross product. So you have, so the 14,000, you're right, that's the cost of moving all of them. But the cost here is, please?
Are we assuming that they're split equally? Or
What do you mean?
once you have to multiply the two, then there's the other ASG1 and ASG2.
Oh, multiplying them together.
Yeah. But you don't know what ASG1 and ASG2 are.
Yes, assumption, let's assume they're uniformly distributed. Okay. Okay.
I have a question. Shouldn't it be union ASD1, union ASD2?
Yes. Yeah. Yes, you're right. I'm sorry. Yeah, you're right. So this is union. And the other one is union too.
Yeah.
Okay. Yes, please.
If that's a union, then it's 415,400 cost.
Okay, if it's a union, it's what? 1,400?
415,400.
Yeah. Tell me, again, forget about the final, right? Yeah. The final answer is not a big deal, right? And how we got to the final answer, that's the thing. So far, she got it right about like when we moved around 1,000 and a 400. So it was 1,000 times 10 plus 400 times 10. So this is the total cost of transferring everything to this site. Okay? And then you want to do a join on that. How are you going to do the join? So the join first, in this plan, you want to select the responsibility manager, which is 20, right? Exactly. So we got 20. So we have 20 tuples coming out of this one, and then you want to join it with the employee. So which is 400, right? It's 400. So 20 times 400 is? So, and add to the 14,000. So it will be, what? Something in 22,000, something like that, right? So the cost, if you look at both of them, okay, we have the plan on this side, we have cost of what? Total adds up to what? 400? Something like this? Around. Forget about like the like whatever, the fractions or anything like this, like 400. And the other one is 22,000. Which one is cheaper in this case? Obviously this one. And it's way cheaper. It's actually an order of magnitude, or two order of magnitude, or 2 orders of magnitude cheaper. So that's a lot of cost, extra overhead. And just, they're both going to return the same answer. And if this system does not take into account what you guys have done now, which is you calculated the cost for both plans, and you chose the plan with the less cost. This is basically what the system does, what you do. However, there is a challenge. Now we consider 2 plans, right? What if we have 1,000 plans to run the query? Like, we cannot do that. Okay, we cannot sit down now and decide this. Okay, but the computer can. 1,000 is easy. I can do it fast. What if I have the search space? I have a lot of joins, and I have a lot of selections, and I have a lot of sites, and I have a lot. And the search space has like millions of possibilities, combinations. The computer still can do that, but to optimize the query, the computer or the system can take an hour to just decide what is the best way to run this query. While if you run any of the plans, it will take a minute. Okay? So in this case, optimization doesn't make sense. You guys understand that. So I'm not going to take an hour to optimize something that in the worst case will take 5 minutes. So sometimes, this is why there has been a lot of research on how to do the query optimization in the most efficient way. Efficient means what we've done now, they want to do it very fast, decide a good plan without spending so much time. And this plan needs to be efficient. A good plan means like with very less cost. So at least if I have the worst case scenario, I'm not going to choose it. If I have the 22,000 plan, this is horrible. I'm just going to avoid it. Maybe there's one that is 400, another one that is 500, the cost. It doesn't matter much. I'm just going to choose any one of them to reduce the search space and get the answer to the optimization fast. hoping I'm just giving you ideas how the query optimizer works. So this is just a breakdown of what we've done now. Query optimization is basically you have a cost function and you want to minimize this cost function. And the cost function in database system is the I/O cost. If the data is stored on disk in distributed sites, there is a cost to get the data. This is the I/O cost in the system. And there is a CPU cost. Once you get the data from disk, you need to process this data somehow, do join, do selection, do some kind of computation in the CPU. And there is communication cost, which is the cost of transferring things around between different sites. The relational operators that we've seen, they have, of course, there's some sort of asymptotic analysis for them. It can give you an idea. It's not exactly, the cost model is not exactly like this, but it gives you an idea what is the complexity of these. So selection and projection, the worst case scenario is n, and n is the number of rows in the relation. The gentleman mentioned in the beginning, if we don't have any indices, anything, we need to scan, and scan is n, right? And then you have, if you want to do grouping or anything like this, or sorting, anything that requires sorting, it's n log n. If you've taken algorithms before, you guys would relate to these kind of complexities. The same for the join, the semi-join, and the join, the worst case can be n squared, which is a Cartesian product down there. But if you have an efficient join algorithm, it can be n log n actually. So optimization strategies, we can do exhaustive search, and this is what I was just explaining to you guys. It's like if I have my search space, I will enumerate all possibilities, and then calculate the cost and calculate the minimum cost. But we said this is not efficient, right? So it's just theoretical, might work, but practically it will never work. And most database systems that you guys are using these days, they don't do an exhaustive search. Definitely don't do that, right? So usually we will resort to heuristics. And heuristics here, it depends on our knowledge of the relational algebra and our knowledge sometimes of the distributed system. So in relational algebra, for instance, if you have a join and you have a selection, it's always better to do the selection first, because you filter out some tuples and then do the join, which is a bigger operation. The same for projection. It's better to push projection down. If you have a distributed system, we're going to see that also. So it's better to push the selection close to where the data is, and the projection where the data is, before you decide to transfer data across the network. Why? Because you reduce the size of the data if you do the selection locally and the projection locally. So these are heuristics. It's not like the optimization function will get it, but that doesn't mean that, but again, the optimal solution will not return, will not be efficient in practice. So this is why we can take these heuristics and apply them directly without doing the exhaustive search. Also, there are several things, also the optimization granularity. So are you optimizing a single query at a time? Or you have a huge system and you have multiple queries and you're doing multi-query optimization. This will make also a difference. Optimization strategies. So you have static optimization, you have dynamic optimization, you have hybrid. So static optimization means that you have a query, you decide what the execution plan, and you go run it. Very simple. This is what we discussed already. So we decided what the execution plan is. But dynamic means that you may change the execution plan on the fly. So while you're running the query, there are new things that you figure during the execution that needs to be taken into account. So this is a dynamic execution plan. So a hybrid, again, is that you compile using the static algorithm, and then you also do dynamic while you're doing it, while you're running the query. So sometimes in dynamic, people don't compile a static plan. What they do is that they start, and based on the current situation, they optimize. Okay. but mostly people do the hybrid optimization. So the system that you're using, like Postgres and MySQL, all of them do static optimization. So you have the query, they decide the execution plan, they compile. There is a compiled code for the optimization, and a pre-compiled set of operators that decided for the execution. Okay? And it chooses among them. And it's static, it runs, that's it. In distributed system, people introduce some dynamic optimization because, again, the situation changes in distributed systems. A major and a very important factor in optimization in all of this is the knowledge of the database of the data that is stored in the database. So any database system that you use, again, in your assignment, you have the ratings table and you use Postgres. Postgres collects statistics about every single table and stores it in one data structure called the catalog. And the statistics are basically, it tells the database system how big is the table, for instance. This is a very simple statistic. But not only this, for every attribute, what is the distribution of the data in this attribute? And based on that, you can determine what is the best execution plan. Because if you have a predicate on one attribute in the table, you can actually decide what is the best, whether to use an index or no. If it's a very selective query, maybe an index would be good. If the query is not quite selective, the attribute predicate, maybe it's just easier to just scan the whole table, and that would be the best execution plan. So these statistics about the data, about the tables stored in the relation database, collected by the system, helps a lot in the optimization. It helps you, most importantly, decide the size of the intermediate results between each query operator. If you have predicates. All right, so in query optimization, the decision, like who takes the decision? Sometimes you have one coordinator that exists in a centralized machine or into a centralized site that collects all the statistics and take a holistic decision for the whole system and tells each site how to run the local queries. And sometimes you do just some sort of pre-optimization at this local site and let each site decide how to run its local queries independently. There's different strategies, and mostly in distributed database, it's actually a hybrid strategy all the time. All right, so it seems like we are done for today. So I'll see you guys on Wednesday. And don't forget the assignment.